All right, so thank you everyone. I'm Timo Muro. Hope you're enjoying the pizza. So I just want to give a little shout out to Lisa Grossbauer. So thank you for making me get my statistics minor. Really appreciate that. And Professor Shi as well. Thank you so much for sticking with me this entire semester. So yeah, about my study. So I wanted to actually get into applied statistics. So I did an independent research with Professor Shi on statistical learning. That's the book in the bottom right corner. And I did a study on MLB's predictability. So yeah, a little bit about my independent research. So it was Stat350 class with Peter Shi. We went through some software in RStudio, just like applied modeling for statistics. And the main goal of my independent research was to actually gain solid foundation on some inferences in statistical learning and how to actually use models on continuous and classification variables, as well as go through some statistical significance on both supervised and unsupervised learning. So yeah, just an overview of my actual course. So we went through classification variables first and how to actually combat those and test if there's significance in any of the variables. So we go through logistic regression, went through linear, quadratic discriminant analysis, k-nearest neighbors, went through into actual continuous variables. So we started with linear regression, moved into simple, multiple, subset selection, so backward, forward selection, lasso, and ridge regression, and then we started to encapture in the end half of the semester regression trees, generalized additive models, and just some support vector machines as well. So the study that I wanted to perform was on MLB data. And essentially we wanted to see if there's any relationships associated with Major League Baseball statistics, and primarily batting statistics. So I was actually this is kind of my baseball background. I was a batter, so I wanted to see can batting alone influence team wins in the MLB. So a little literature behind it. In Briggs 2008, he essentially he ran a multiple linear regression on batting average and ERA alone, and he determined that only pitching was significant in determining team wins. So I wanted to actually see, can batting actually determine team wins as well. And in Hauser 2010, ran the same type of multiple linear regression, except he added in a lot more variables. And he concluded that on-base percentage and walks and hits per innings pitched were statistically significant. So that kind of geared me towards, maybe there is some statistical underlying in batting performance for team wins as well. So the data, I used 2016 MLB data, gathered all 30 MLB teams. So I essentially got the whole population for 2016. And my targeted dependent variable was number of wins, where I had 26 independent variables or predictive variables as well. And the first thing I pretty much did was I split the data into both a training set and a test set. And the reason behind that is because I wanted to see essentially, can one set of 15 MLB teams explain the variation in wins for the other 15 wins? So yeah, just a little bit of just some histograms of the variables I used. So you kind of see that there's actually no real skew or anomalies in the actual predictive and unpredicted variables that I used. And just some weak assumptions right here. I assumed normality from the central limit theorem in order to run multiple linear regression. And then I also did a correlation matrix of all variables, and these are some of the variables that kind of stood out. So as you see, when you have at-bats rising, you kind of expect the player to get more hits as well, so you don't expect them to always get out. So there was definitely some multicollinearity in there, and that allowed us to actually use ridge regression and lasso regression. So getting into some unsupervised learning, I did a principal component analysis for subset selection, and this chart right here might not really make sense, but essentially all it shows is that when you add more predictive variables, the residual sum of squares and the adjusted R squared, they're going to actually be synthetically modified. So the more variables you add, the more they kind of explain the variance within the data set. So here we kind of see diminishing returns after the fourth and fifth predictor, which is kind of what we expected. And then just some naive testing. This is the first thing that I essentially did for just linear regression. I just put all the 26 predictors into a model, wanted to see what happened. So essentially I didn't really find anything. I didn't have statistic of 0.742, that's really low. I was hoping it would be a little higher. And essentially I found that no predictive variables were statistically significant. and determining the variation in team wins. Moving on to that, I then looked at partial least squares, and essentially I wanted to see what variables matter. So we found that two-component least squares regression minimalized test MSC. So essentially, what I did was I did a cross-validation. I wanted to see, what actual components lower the test MSC. So I used the training set obviously to test the test MSC, and we found that two components minimize test MSC at 198. And then just some shrinking methods. I wanted to see which models actually we should use in the future. So we found that both Ridge and Lasso are pretty good at explaining the variation in wins from Ridge regression, and we found that that actually had the best test MSC, so that essentially it explained the variation in wins the best on the test set. And we've also found that in Lasso regression that the key variables of use in hitting were both the age of the player, RBIs, and then on-base percentage. And you might think, how can on-base percentage have 100 or cause 191 wins in a 182 game season? And that's simply just no team can actually get a hit or a walk every inning, every at-bat, every game, and there's just no possible way that one team can always either get on base. So that's kind of why it's so high, because normally we expect on base to be 0.35, 0.4, and yeah. And just some conclusions and inferences. So we did find that in Hauser 2010, on-base percentage was statistically significant in determining team wins, and in my Lasso regression I actually found that as well, which is pretty interesting. But overall, Ridge regression definitely performed the best in the test set with a mean square error of 53.5. And also it's sometimes it's just hard to run tests when there's so much molecular linearity. So if you get a ton of hits in one game, some of those are going to be doubles. So when hits go up, you're expecting doubles to go up as well, so there's just some correlation in between those, and it's hard to account for all of that. But yeah, thank you. Any questions, concerns?